Hello students. So today's session we are going to discuss the JEE Main 2024 problems on these topics, right? So I have already made the solution so that in order to save the time we will be quickly rushing through the solutions, right? So let's start this. First, what is given? First question. A particle moving in a circle of radius r with uniform speeds takes time to complete one revolution. So t time it is covering one revolution. So speed we can calculate speed is equal to distance by time. So in one circle it is going to have a distance of 2 pi r, right? 2 pi r divided by time t. Okay. Right. Then they are saying if this particle is projected with same speed at an angle theta. Now they are saying that we are projecting it at an angle of theta, like this is projectile motion based question, right? Then we have to find out, and they are saying the maximum height is equal to 4r. Maximum height is 4r. The angle of projection theta is, what is the angle of projection theta? Okay, so maximum height is given as 4r. Now maximum height is equal to u square sin square theta by 2g. Direct formula will use, right? So from here sin square theta will be 2g h max by u square, right? Then after that we'll just try to find out sin square theta, that's all. So sin square theta and h max substitute value 4r. Here you may confuse with the symbol capital R. Capital R is not the range. Sometimes you may get mistake, right, because of this. So you should know this capital R here is not the range. It is the radius of circle, which was first condition. Okay, so based on that you are solving it. Okay, so 2g t square, just substitute that and simplify, you will get sin theta. So that means theta is sin inverse of this. So you will be getting the first option, right? Okay, so let's move to the next. Next question is, if the radius of curvature of the path of two particles of same mass are in the ratio. Radius of curvature ratios are given. Then in order to have constant centripetal force, their velocities will be in the ratio. So centripetal force formula all of you know, mv square by r. Here of course mass is same. Same means both the two bodies which they are comparing, they have same mass. Okay, and they are also saying that centripetal force is also constant, it is same. So we directly can say v square is proportional to r, so v is proportional to root r. So the ratio of velocity v1 by v2 is root r1 by r2, and they have given the radius ratios, right? 3 by 4, so root 3 by 4, root 3 is to 2, right? So that's the first option, right? Then let's move to the next question. Let's understand what the question is. A ball rolls off the top of a stairway with horizontal velocity u. The steps are 0.1 meter high and 0.1 meter wide. Okay, and the minimum velocity with which that ball just hits the step 5 of the stairway will be this, where x will be. So let's understand what this question is. So first you need to understand this diagram. Okay, so let's see that. So this is like a stair. First, this stair should not be counted because on this stair itself this ball is rolling, and from this stair it is falling. So it will be hitting this next. Suppose if it hits next stair, that will be the first stair it can hit. Then this will be the second stair, then next third stair, next fourth stair, next fifth stair, like that. Now if this is going to hit the fifth stair minimum velocity, so it should just keep like a touch the this here, isn't it? The fourth stair at the corner, it should pass through that corner, touching it slightly, so that it will be just able to. They may also ask maximum velocity. So if the maximum velocity to just hit 5, then it should pass through the corner of 5. Understood? So there will be difference in that case. But minimum velocity to hit 5 means it should touch the corner of 4th, previous one. Okay, and each height is, let's say hh, they have given the value of h. So but they may have different values also, but here it is like same value. So h we can note. So suppose it is hitting here, so from here you can measure it from the beginning. So this will be 4h, right, because it is 1 2 3 4 fourth h. Similarly, when you take bottom height, this is also 1 2 3 4, right, 4h. So if it is going to hit minimum velocity fifth one, that means it should be like 5 minus 1 fourth it is going to be. So here this horizontal distance and vertical distance, we know 4h. Let's say horizontal distance. So this distance is speed into time, because this is speed in the horizontal direction does not change, right? And this time for the vertical, time, it's a free fall, because in vertical direction there is no speed when it was thrown horizontally. So vertical direction, the time formula is root 2h by g. H is here 4h, the total height from which it is falling, right? So substitute this is root under 8h by g. Then this time you substitute it here. 4h is equal to u root under 8h by g. After that, what you can calculate u. So try to calculate u, simplify from here, and you will be able to calculate u. So finally you will get u as 16h square. H also cancel. You will get finally root 2gh. Then substitute to g 10 and this h is 0.1. You will get this as root 2, and root 2 is given as root x. So then we can compare and we can say x will be 2. Right? So in this manner we can calculate this. Okay, let's move next. Next question, particle of mass m projected with the velocity u making an angle of 30 degree with the horizontal. So this is making 30 degree with the horizontal. Magnitude of angular momentum of the projectile about the point of projection. So about this origin, let's say this is origin, about this point, when the particle reaches maximum height, that time angular momentum is. So first of all, this diagram should be clear. Let's make this diagram. So this diagram, you can see here that this one, this diagram, you see this h max, this is the maximum height h max, right? This h max, and then this is u, this is angle theta, okay? And at this maximum height, it has only horizontal speed u cos theta, vertical there is zero speed. So angular momentum about the origin is r perpendicular into p, right? R perpendicular means this is the line of motion. This line of motion, what is the perpendicular distance from here? That is r perpendicular. This is equal to h max. So h max into momentum at that point. That point momentum is m into ux. So m into u cos theta. So just substitute the value h max into m ux. Ux is u cos theta, and then from here you will be calculating angular momentum. It will come, right, root 3 by 16 m u cube by g. So that will be the option number. Okay, this way you can solve it. Then let's go to the next question. Is a projectile, two projectiles A and B are thrown 45 degree and 60 degree. Suppose if you throw a projectile at an angle theta, here theta, remember theta is with respect to vertical. Okay, so this is theta. So if you resolve this velocity, this vertical will be u cos theta, this will be u sin theta, because theta it is making with the vertical. Okay, and this height from the ground, this building height is 400 meters. Okay, if their ranges and time of flight are same, they are saying that their ranges and time of flight both are same. Ratio of the speed of projection VA by VB, what is that? So first of all, we should note here important thing that time of flight, right? This, suppose this is the range, and this side the speed is v sin theta. So time is distance by speed. Distance in horizontal is r, speed is v, because horizontal motion is a uniform motion, right? So this would be time of flight. If you take vertical motion, that will be minus, because here directions are important. Suppose I am taking downward direction negative, upward direction positive, right? So downward displacement is minus h, right, is equal to ut, u is v cos theta, ut minus half g t square, right? So from here h will calculate. Now see, they have given two different projectiles. Now for the time to be same, range is also given same. That means v sin theta of the first one, V A sin theta A and V sin theta B should be same, but sin theta A theta B are different, so VA VB must be different. VA VB cannot be same, isn't it? Now if you see this side, let's say this side vertical component, so here V cos theta and this V cos theta A, VB cos theta B, right? So this should be same, then only H will be same, because second term is constant, and here this V cos theta should be same. That means both their y components and both their x components should be same. This is not going to happen, right? Why? Because if you try to equate it, it will not satisfy that. And you can logically think, if everything is same, then their velocities should also be same, right? Both should be projected at the same angle theta, then only it will come same distance x, same distance y in same time. That can only possible when their velocities are same. That means they should be projected with the same angle, right? So here they are projected different angles, so none of the option will match here. Neither sometime you may think that the velocities are same, so but angles are different given now. So because angles are differently given, so we cannot say this also, right? If they would have not given different angle, then we can say that they are same velocity, same angle, everything can be same, then 1:1 was possible. But in this case nothing is possible, right? So that's why it is none of these options are correct. Okay, next let us say this body starts freely falling, okay, from a height h, hits inclined plane, it's fast. So the body is dropped here freely falling and it is going to hit inclined plane. Okay, so this height of this ball initially was capital H, and where it is hitting, that point is at a distance of small h from the ground. Okay, so after that it is saying that the directional velocity become horizontal, that means it becomes horizontal, right? Vertical it won't have any component. Okay, so it will go projectile motion, then this will be a horizontal projectile motion, right? Now total time, if you see, so first of all there will be time h minus h from here, and then this time, two different times you have to take. Now here both time formula we can write root under 2h by g, because in the first case it is dropped, so there is no vertical velocity, right? Second case, after collision vertical velocity again becomes 0, so it is vertically, it is free fall only, right? So root under 2h by g, h for the first case is h minus h by g, second case is root under 2 small h by g. Now if you just try to find, you want to get maximum value of time. To get maximum we have to differentiate with respect to h. H is the variable here, so differentiate time with respect to, this is a problem where you are differentiating with respect to h. Time we are differentiating, generally we differentiate everything with respect to time, right? But this case we want time to be maximum, so time depends on small h, so we have to take maximum minimum concept, right? Differentiation of time with it. So root 2 by g common, then differentiate this, root h minus h, root h, it should be 0, so this is 1 divided, that's at 0. Now root of this with respect to this is 1 by 2 root this, and then h minus h with this h is minus 1, right? And similarly root h is 1 by 2 root h. So you solve this, from here you will get to small h is capital H by small h is equal to 2. So the correct answer is going to be 2, right? So I hope you have understood these solutions, right? So these are the recent year questions. Now you can work out more questions on this. So we are done with 2D motion in a 2D plane, right? Circular motion and all other things. So then we will be moving forward with laws of motion. Thank you for your attention.